In this video lesson, we're going to review the product and sum pattern, or product and sum rule, that helps us quickly expand and factor. Keep in mind that the product and sum pattern only works when we have one x squared. So we say that this fits x squared plus bx plus c. In this case, our factors will be x and a number multiplied by x and a number. The numbers that we fill in are two numbers that are going to multiply together to give us the c part, the ones, and add up to the b part, the number of x's. We can connect this to our algebra tiles. The two numbers come from our edge lengths, and the ones come from those edge lengths multiplied. The total number of x's come from adding together each of those rectangles. Using our product and sum pattern to very quickly expand, we know that we're going to have one group of the variable squared. Positive 6 plus negative 1, we're going to have positive 5c's, and positive 6 multiplied by negative 1, we're going to have negative 6 ones. We're all finished and don't need to show any other work. So in this case, the expansion will involve n squared. 12 plus 7 will give us 19 n's, and 12 multiplied by 7 will give us 84 ones. Finished. In this case, we're going to use our product and sum rule to expand the two binomials first. We certainly could expand 3 multiplied by x subtract 8, but it's easier to use our product sum rule. Now we're going to look at 3 multiplied by x squared for 3x squared, 3 multiplied by negative 17x for negative 51x's, and 3 multiplied by positive 73 for 219 ones. This is also a nice time to point out to grade 10 students that 3 only multiplies through one time. It doesn't get shared with the x subtract 8 and the x subtract 9. This is why it's useful to use the product sum rule first. That'll protect us from any mistakes. When you're going to use your product sum rule or product sum pattern to factor, keep in mind that you're always going to check for a common monomial factor first. And before you decide to use product sum rule, check to see if this is a perfect squares or a difference of squares pattern. They're pretty fast to use. Once you decide to use product sum rule, start to do some mental math. We're looking for two numbers that multiply together to produce 18, and the same two numbers have to add up to equal 11. Have you got the two numbers? 2 and 9 would work quite well. We fill those two numbers into our factors, making sure we're not making any errors with the signs, and we're all finished. In this example, we're looking for two numbers that are going to multiply to 12 and add up to negative 8. Since they multiply to a positive number but add to a negative number, we get a hint that both of these numbers should be negative. And let's see, negative 2 multiplied by negative 6 will be positive 12, and negative 2 plus negative 6 will give us negative 8. Looks like we found our factors. Try using the pattern in this case. Here we need numbers that are going to multiply together to be negative. So one of the values will be positive, and one of the values will be negative. The same two numbers have to add up to positive 3. So that tells us that the larger of the two values has to be positive. And we start to play with our mental math again. 20 multiplied by 2 doesn't work, and 4 multiplied by 10 doesn't work, but 5 multiplied by 8 fits the bill, so the larger number, the 8, will be positive, and the smaller number, the 5, is going to be negative. This last example doesn't look like it's going to fit our product sum pattern. We have more than one of the j squared. But I also notice that 3 is a factor of every term. There is a common monomial here, so we factor out. And now what's left over does fit our product sum pattern. we're going to look for two numbers which multiply to -5 and add to -4. We know that since these multiply to give us a negative value, one number is positive and one number is negative. Since they add up to be a negative number, the negative piece has to be the larger value. And now we start to play with mental math. Eventually we realize that the only two numbers that work are +1 and -5, so we finish our factors. And notice that that 3 we originally factored out is still part of our final factored form.